Ladies and gentlemen, we are starting with our next panel discussion, that is India's Semiconductor Leap, Building a World-Class Ecosystem. As a moderator, we have Mr. Sudhir Narayan, partner Bain & Company. Can we give a huge round of applause as we welcome him on the stage? Mr. Sudhir Narayan is a partner in the Bain Mumbai office. He's a leader in the global technology practice, specializing in semiconductor and electronics engineering and R&D. Over the past 20 years, Sudhir has advised clients across a variety of sectors on growth strategy, business diversification, M&A, cost optimization, and operating model transformation. On the panelist, we have Mr. Ellen Chillen, the Vice President and Managing Director of Sanmina India, who has been joining us as a panelist for India's Semiconductor Leap. Since 2007, he's associated with Sanmina's India 100 acres integrated manufacturing campus, which is providing end-to-end solutions, delivering superior quality services to world's leading OEMs in medical, telecom, automotive, industrial, computing and storage, defense and aerospace segments. Can we give a huge round of applause once again, ladies and gentlemen, for Mr. Ellen Chillen. We also have Dr. Ravi Bhatkal as our panelist, who will be joining us, PhD Vice President, Strategy, McDermott Alpha. Dr. Bhatkal also teaches a course titled Fundamentals of Semiconductor Packaging Materials as a part of BITS Pilani Crest Professional Development Course. And Dr. Bhatkal has served many significant roles as the Electronic Manufacturing Committee of American Chamber of Commerce India, Research Advisory Board member at the Central Manufacturing Technology Institute, Bangalore. Dr. Bhatkal's early experiences include roles in R&D in India and management consulting, as well as building an advanced materials startup in the USA. Dr. Bhatkal earned a PhD in Material Science and Engineering and MBA from Rensselaer Polytechnic Institute, USA, and MS in Material Science and Engineering from Vanderbilt University, USA, and BE in Mechanical Engineering from the College of Engineering, Pune, India. Is widely published, a frequent speaker. So let's give him a huge round of applause, ladies and gentlemen. And on the panelists, we also have Mr. Paul Ilangovan, Head Operations, Keynes Semicon Private Limited, who is joining us on the stage, having 3 decades of industrial experience, in which 26 years in semiconductor OSAT business. Expertise in manufacturing operations, where introduced various methods to enhance employee productivity, yield improvement, cycle time reduction. In addition to operations, Mr. Paul handled project management and business development. Successfully played key role in establishing first memory manufacturing greenfield semiconductor company in India, in Bhiwadi, Rajasthan, and India's first indigenous semiconductor assembly and test facility, Brownfield in Bengaluru. Let's give a huge round of applause for our moderator and our panelists. Over to our moderator.
Good morning, everyone. So, this is a topic which is apt for this event. The reason I say so is I think Elsina's mission is to build the ecosystem. They have been at it for 55 years. It takes people say if you have, if all of you are will have children back at home. It takes a village to raise a child. It takes an ecosystem to raise an industry. So it's a very important topic. I think each leader here on the dais is extremely passionate and knowledgeable about this space. We, over the last 2 days, have heard multiple things about scale, how to bring in more upstream, downstream participants, how to bring in innovation, how to build competitiveness for global market. All of that will be possible if you think of it from an ecosystem angle. There is an element of competition that each individual company will be going through, but there is also an element of having a combined vision of all India participants working together to build this ecosystem. So I'm thankful to Shashi and the team to give this opportunity to have this conversation today. I'll take just a few 5 minutes to set context, and then we will invite my panelists to share their opinion. When we talk about electronics and semiconductor value chain, it is actually, it's not a homogeneous industry. It's, according to me at least, an aggregation of 30 odd sub-industries, right from, on this chart, from the rightmost, from assembly, what is required for a large volume consumer assembly to a very specialized specialty serving medical, aerospace, defense is very different. Components is a whole host of family of components from sensors, electromechanicals, PCBs, discretes, and so on, battery. Each of this is a ecosystem by itself, which has its own supply chain of raw materials, quality systems, testing certification. Then go backward into packaging. There's traditional packaging, all which is rapidly moving into different technologies of advanced, a spectrum of what we call as advanced packaging technologies, to different ways of building the chip itself, and then the design and core IP. But last but not the least, the equipment and raw materials, right? There's a whole host of equipment, right from production equipment to testing, ATEs, metrology, bulk gases, substrates, all kind of packaging materials. So the reason I thought of bringing this up is to show the spread of what we are talking about. And this is only the business segments within the value chain. For each of this value chain, there will be a set of suppliers. Both core suppliers and indirect consumable suppliers, which is required for this industries to be competitive. And yesterday, I remember someone, I think Shashi only mentioned this point, that when we think of scale, each factory in, and we often take example of Shenzhen, is 3-4 football fields size. And that brings an end to enable that it is, it's taken multiple years and decades to get there. And I'm not sure we need to build another Shenzhen, but the vision should be something similar to that. Right, so both in terms of scale and depth. And the unique part that I wanted to highlight or share with the broader audience here is, in this industry, there is no country which knows it all or does it all. Japan has a leading position in materials. Europe and US have leading position in equipment and design. Taiwan and China take a leading position in manufacturing. And we are starting to gain at least incremental market share in assembly and hopefully in components and system design and chip design going forward. So it is also, there is an element of strategically picking the spaces that we need to build the ecosystem for, not bite more than what we can chew. And we also need to understand this is not a sprint. This is a marathon. If I look at all the other equivalent geographies, they have built their ecosystems over 40, 50 years. Electronics and semiconductor, even though we are moving on a rapid growth path over the last 10 years, even Indian ecosystem, Elsina has been around for so many years. So it's, the industry is that long, and it takes a long marathon to build the ecosystem out there. And I would just touch upon a couple of examples of, and I would request a panelist to share examples. From my experience, all of these ecosystems are clustered around specific geographies, right? Even within Taiwan, there are maybe 2 clusters where all the fabs are clustered. In China, there are maybe 4 or 5 clusters. And India also, organically, we are having a few clusters which are coming up. But it requires multiple dimensions to work. Land is a very important key element, continuous land, to avoid last mile logistics complications. So from whoever is able to influence that, there needs to be planned to say, we are at a particular scale. For 5x the scale, do we have enough space to expand around that cluster? Or we will run out of it and we'll have to find another cluster just because of space issues. Talent, extremely important. And talent is not unidimensional. There is talent at a senior management level, different levels of mid-management level, and different levels of specialization which is required to operate the business, both on the front revenue, sales and marketing side, and on the technical side. And I think we talk a lot about technical talent. I think India needs to also attract business talent which is capable of selling semiconductor and electronics going forward, and it's not something that we are naturally good at. I think technical STEM training happens through schools, selling and marketing happens through practice. There is infrastructure, which is specialized infrastructure, which is required for all the 30 different subsegments I spoke about. The infra requirements would be different. You are handling toxic gases, high purity elements, safety, high trust, logistics. We are excited about Indian government doing incentives, but that's actually par for the course. If I look at the big fund in China has contributed almost over the years, over the last 40, 50 years, close to $95 billion into this entire value chain. We are at $10 billion, not yet spent fully. But I think from an ecosystem perspective, it all needs to add up in terms of building profitable businesses. The incentives can't go to waste because it's all our individual tax-paying dollars. But it is important to understand that we are competing against ecosystems. India as an ecosystem is competing with Vietnam and China, and think of it as aggregation of P&Ls working at a government level. So the government level support is not because the industry is weak, but it's required structurally because other competing ecosystems are doing the same. There is supplier ecosystem. We need to partner with Japanese companies, German companies, US companies to have their partnership to supply this. Having the right R&D governance at local level in terms of clearances. The reason I wanted to bring up this page is, and there is a lot of details out here, is there has been a very thoughtful and intentful effort by competing ecosystems in Singapore or China to build this out on a multidimensional basis. When you are building out a company, you might think of what is required for you for the next 3 years in terms of talent, in terms of land. But as an ecosystem, you need to have a much longer horizon to do this. And all of this will enable you to not be on that hard treadmill of building every year on year, right? If the ecosystem is set up, the individual participants in the ecosystem will find it easier to scale up further. I would leave with this as the page to maybe we discussed as a group here. In our view, when we say ecosystem, I'll break it down into these 6 elements. There is access to design, which is the leftmost, and then there is access to customers. To do all of this, we need 4 things. We need hard infrastructure, which is manufacturing infrastructure, logistics, office and living space. There is talent and innovation at all levels. There is the supply of power and water and all the utilities, and then enabling your supplier ecosystem out here. With that, I just want to define what ecosystem is, but I would invite Ilanjayan to share his journey so far. What has he seen which energizes him from an ecosystem development point of view, and what is, from his vantage point, where does he see the future priorities being?
Thanks, Sudhir. Excuse me, I have a little bit of sore throat. Good morning, all. Thanks, Asi, Raju. Even during a difficult time in physical challenges, you could be able to come to the session and making it successful. Once again, thanks for Elsina. So I'm still remembering my days when I relocated back to India in 1990 later part. Some of my customer requested me to import the pallets from Europe. That's what the situation. So give a background, I represent Sanmina. We have a 100-acre manufacturing campus. We serve all the top OEMs of the world in the technology products, in medical, defense, aerospace, automotive, and high-end computing. So that was the journey when we started. It was a surprise. I just asked my team, hey, we have 1 billion people here. Why we need to import a pallet from outside India? That's a real situation in 2000, early 2000. And we come across a lot of learnings. And good thing what we see in India is the attitude. The young population, the attitude to change, challenge, and improve. So that was the thing brought us from that importing that such a things. Now we are not importing any electromechanical parts. That's a tremendous transformation what we have done. I think all of us know that in electronics, out of $100 BOM, $80 bill of material come from electronics. And remaining $20 come from electromechanical and packaging, other things. The remaining 20% we could able to successfully do it in over last 1 decade. That was the ecosystem. It doesn't mean that only kind of trying to localize. We continue to invest in technologies. You can take it as 2K molding, or you can take it as in-mold decoration, or very fine coating of copper, silver for filters, or any medical devices. So many technologies continue to invest in our place and in our supplier place so that we make a stickiness with our customer. So that was the journey in the EMS environment. And I can talk about so many things, product which is very closer to my heart as an Indian. As Sasi always mentioned to me whenever he met me, he said, hey, you are the guy making supercomputers for India. So we are the proud manufacturer for making supercomputers for India. Not only that, so we do OBR reagents, which is a tuberculosis detection solution, which can able to detect within hours time rather than a week's time. And then we can say these Aadhaar or latest technology, telecom or medical devices, so many things which is helping fellow Indians. So, and a good thing what I see in terms of our overall Indian ecosystem is, during the COVID, we never shut down a single day. We got all our approvals to our governments through the WhatsApp message. That's what the great ecosystem what we have in India and in Tamil Nadu. The bureaucracy is no more during the difficult times. That's a fantastic one. Coming back to the stage, I feel like human having essential things. We can say air, the thing what we breathe. So the semiconductor become air now for the industry. Without that, we cannot survive. So semiconductor is a very essential things to survive as a human. You take anybody, whatever gadgets we have, whatever things we have day in, day out, the semiconductor is a core thing what we need to live with. And what we see in overall, we could able to do the better ecosystem, improving our value addition, supply chain in other industries. You take automotive, we have all the OEMs in India, and we have localized everything. But in electronics, now we are on the path. So I think with the right mechanism and long-term vision, like immediate, short-term and long-term, we could able to achieve. If I want to a little bit go down, what the other countries does is, they make some sticky point. As Sudhir mentioned, Japan is controlling the material science and then precision equipments. US is controlling almost 40% of technology. And what South Korea make dependency on them is all memory chips, you need to go to them. So Taiwan, foundries of the world. So there are a lot of things we can learn from other countries, proven things. What we have advantage is, we have a great demography, talent, and then the good governance now. So we could able to leverage it. Probably in the next round we can deep dive. So let us pass on and then move on to the next one. Thanks.
Thanks. Ravi?
Thank you, Sudhir. Thanks to Elsina for inviting us here. And, I think it's a incredibly exciting time right now in India. It's a long runway. It's a tremendous future ahead of us. I think it's up to us to make it happen, basically. So about you asked us to talk a little bit about where we come from and what we do. So McDermott Alpha is, we used to, by the way, be known as Cookson in India for a long time. The roots, our parent company right now is called Element Solutions. We are a US public company on NYSE. We are probably one of the only companies that goes from chip to box. We are an advanced materials and specialty chemicals company making back end of line interconnect materials at the wafer level. So all the fabs are customers, all the advanced packaging houses and um, packaging houses that do power, logic, pretty much every kind of device. They're customers for packaging materials. IC substrate materials and chemicals, we make those for the industry, as well as PCB materials, PCBA materials, PCB assembly materials, which we have scaled in India in a very big way and globally as well. And then at a systems level, thermal management and encapsulation and all kinds of protection materials. So we basically go from chip to box, chip to system. Every layer of the electronics industry is a customer. We're in about 50 countries. In India, we have a long history. We've been manufacturing in India as a multinational for 95 years now. And we've been really helping to build the electronics industry in India for the last several decades. And the team is here. Richard leads our business development, and he's been working to really build he and the team have trained about 11,000 engineers at our customers over the years. So it's been a long, deep involvement in the industry for the company. We have manufacturing facilities in Chennai and Pune for different product lines. Our global R&D center is in Bangalore, in Aerospace Tech Park, right next to the airport. It's one of our largest globally and pretty much one of the most advanced. And we have a technical center in Delhi. So, we have designated India as a strategic region for the company. My role has sort of evolved to that now, to basically be responsible for the long-term growth of the company in India. This is an apt panel because we are very deeply involved in ecosystem development on a whole host of issues. So look forward to talking about the rest of the stuff we want to talk about. But yeah, it's a tremendously exciting time, and we're working to bring our technologies and businesses to India one by one. I have been doing that over the last 9 years, but going forward, it'll be progressively a lot more advanced as we move forward. Thanks.
I think it's also very thoughtful from Elsina team to bring in the panel of this background. I think with high-tech manufacturing represented by Mr. Elanjiri and materials and being in the industry for the last many years and global company operating out of India. And now I'll go to Mr. Paul, who's now setting up a greenfield plant. And he comes from he's an industry veteran, but he's setting up a greenfield plant in a space which I think is just vast stretches of land. Over to you, Mr. Paul.
Good morning, all. Thanks to Elsina for giving me this opportunity. I've been associated with Mr. Raju for a very long time. When we talk about my company, I'm from Elsina, Keynes Semicon, which is a subsidiary unit of Keynes Technology, which are in the business for more than 4 decades. They are mainly in the EMS business. So we have about 16 facilities across India and some in outside of India also. This Semicon is just started. We are about 12 months old, and we were successfully produced our qualification lot for our first customer, and which are all in the reliability test now. So our pilot line is ready, and now our main plant is in construction, which will be ready by mid of this year. So our package roadmap is to start with initially on the legacy packages like the power modules, the TOs and the QFNs. And later we will move on to the BGAs, flip chips, and photonics kind of packages. And in addition to that, we are working on several other capabilities where we will be into camera modules and smart card manufacturing also. So when we talk about this semicon, actually India has a very long history, particularly in the semicon field. You know that in the late 1970s, then Prime Minister Indira Gandhi was established the semiconductor laboratory in Chandigarh. So that was the one which established before many of the countries have landed into semiconductor field. India was a preliminary one, but unfortunately something went wrong. The complete plant was burnt, fired. Till date, we don't know the reason why it happened. Could be something else, politically, geographically, we don't know. But India was a pioneer one, in fact. If it goes well, then perhaps India could be the top one in semiconductor as of now. Later again, the same ACL was established, and there, after a long gap during Dr. Manmohan Singh's period, we planned to establish, and we signed actually 2 MOUs for the fab. But again, it didn't go well. But after our current Prime Minister, Mr. Modi's period, they have given more importance to this, and finally we are here. Now the globe, due to geopolitical, most of the companies are moving out of China, and where we have the opportunity now to grow. So there are 10 semiconductors being approved by the government, and 4 is in place now. The top players like Micron, Tata, CG Semi, and Keynes, the 4 the major players, and some other small players are in this business. Though the 10 players are here, as mentioned here in this slide, there are plenty of challenges we face. Probably in the next other rounds we may discuss on that, what are the challenges and how we can address those. It's an opportunity for many of the industry people and in fact the academic institutions as well. So let us continue on that. Thank you, sir.
Thank you, Paul. So I think Paul mentioned there are many electronics manufacturing units all over the country. But if I look at packaging and fab, there are 10 projects which have been approved. But there are few other OSATs which are already present in India, SPEL, Sasra, and others. And there would be at least 100 odd component plants coming up. And the EMS plants are only going to scale in, I haven't visited a Foxconn facility myself, but I can only imagine how large it would be, or even Sanmina facility, not able to visualize what 100 acres looks like. But it's going to grow threefold. The question I'm making is, 10 projects which have been approved, ISM 2.0 will come in, maybe there's ISM 3.0 in the 5-7 year time frame. There might not be one fab, there might be 4 fabs, 20 packaging, 20-30 packaging lines, 200 plus component entities, and really large scale, and I'm not even talking about input materials. The question I want to get your vision on is, how do you see our readiness to go through the next level of journey? Do you see the industrial ecosystem coming up in the, what areas are we in the right direction and what areas requires focus?
Before I answer the question now, the world global power is defined not by military power or the economic power. It depends upon the core technology which country is investing. If you see, the 20% of the fab design is done in India out of the whole world. So we are doing the upstream and downstream like manufacturing of technology products. So we are missing the centerpiece. So that is a very, very sweet challenge what we have, because we know the core design of the chips and we know how to use it smartly. We are missing the middle part. And the advantage of what we have, just now I was talking to Mr. Paul, why everybody goes to Gujarat? Because you have a crude oil there, you have a lot of chemicals, you have gases. Those are all the things needed for semiconductors. And then we have a great talent in all major metro cities. So there we are tapping our soft skills. And what we are looking at now is, yes, this is a very, very huge challenge. Because as of now, India's contribution is less than 0.2 percentage in terms of the technology for the whole world. However, achieving 2 to 3 percentage itself a very difficult target, but we could able to see based on the current situation in next 3 to 5 years, I am very confident with the technology skill set and the ecosystem of all these material science. We have a Ravi here. We continue to see good innovations in India in terms of material, not just importing material or trying to localize the material. No, you should find some new nanotechnologies, metallurgy, invention should come, that is coming. So that is going to reduce your dependency on other countries or other players. So we are going to have a homegrown technology. We have a great talent already. We have an ecosystem of land or surplus things, all other things are there. With this, I believe that within 3 to 5 years, we could able to, my estimation shows that currently, for example, for $100 billion worth of manufacturing, we are importing $80 billion. I think this $80 billion, at least 80% of it will come from India. Classical example is our Indian conglomerate now realized they start to invest. For example, Tata is going to get all their chips from their PSME partnership. That's a very smart move. All the automotives of Tata are going to use their own chips. So it's a dual benefit. So we are bringing technology, we are going to innovate the technology, we are going to manufacture by ourselves. It's nothing but end to end. And all our players going to make those chips and all the gases, material technology going to come from there. So that's a one piece of thing. Like this, the other conglomerate already started to wake up, already started to work on, a lot of projects are coming in. As you said, $10 billion still not utilized. It's going to come more. So based on my guts feeling, I feel that 80% of the parts what we are importing, it will be locally manufactured in 5 years time period. Not ending there. We need to become a surplus, and I believe at least we should get a target of 20 to 50 billion worth of chips we should export. So that's what what I foresee in next 5 years down the road, based on the current ecosystem and the challenge we take as an opportunity. Yeah.
Yeah, I think maybe I'll add to what Elon just said. So if you map out the evolution of the ecosystem in India, we started with systems integration, essentially. We have migrated to, not migrated, but we have added board assembly, really, and that has scaled over the last several years, and now it is sort of going vertical. Now we're adding the components piece, PCB, through ECMS and capacitors and other things, and then of course the OSAT and IDM operations that are coming online, as well as the first fab with Tata, etc. So we're moving up the value chain clearly. But what is required is the build-out, complete build-out, as Ilan mentioned, the complete build-out of the ecosystem. So in any one of these nodes, let's take board assembly or packaging, etc. What we need is a systematic understanding of what is there, what is missing, and how do you fill the gaps. So people, number one, right? The right people, properly trained and educated, underlying all of this. The inputs being materials, components, equipment, and then the key enabling activities being design, modeling and simulation, manufacturing process, development, and testing and reliability. So from fab to packaging, to board assembly, to systems integration, these elements are critical. And they're different for each node. They're not the same. So we have to systematically go about sort of mapping and building. It's like, I would call it jumping from one running train to another, because you're building out and you're acquiring capability at the same time. And frankly, I would call it a belt and suspenders approach. It's and. It's developing locally, it's licensing technology, it's inviting people to come and set up, It's building out the corporate capabilities domestically. It's doing startups, investing in universities and research institutes. All of the above is basically required simultaneously and on a redundant basis. Not just one effort, but actually redundant. And that is required because you're trying to compress a huge amount of development in a short period of time. What China took 30, 40 years to do, we are trying to do in a dozen years, right? And for that to happen, you have to parallel process. So that's a quick take on it. I think, from our standpoint, we, as I said, we are bringing our technologies one by one to the country. We're scaling. All of that is happening from a material standpoint. But there's a huge, when you start looking at what is the opportunity across the board, it's significant because it's not just about putting a fab or a OSAT unit. It's hundreds of things that feed into that one fab or one OSAT that are required. And that has to happen, you have to have significant local presence. If you take materials is one aspect, but equipment is another key one, right? Having the ability to, hopefully design and manufacture equipment, but definitely to at least have maintenance and serviceability and spare parts and components available domestically. Your line goes down. If you made $1 billion investment, you can't afford to have any downtime on that. So, those are the things. So every aspect, we just need to, do it in a coordinated way. Does that help?
Yeah, to address the question, what is the readiness of this? I would say at this point, I should appreciate our government's initiative and government support. Because as far as the semiconductor is concerned, I think the federal government has given a clear idea or clear permission to all the state governments to support whoever comes into the business. Because we are working with Odisha government also on some other project where we have seen that the support is very excellent. So which means this encourage the companies to start this project. However, we are having some nitty-gritties into that because for the semicon industry, maybe if you consider 10, 15 years back, the PCB market, India was in most of the items were been imported from China or somewhere else. But government has introduced to develop the PCB market and now we are matured in another 10 years time. Similarly, as of now, the semiconductor industry, it doesn't have any ecosystem in India because when we go for the equipments, when we go for the raw materials or consumables or even the support systems, almost 98% we have to depend on importing. As rightly mentioned that, we have to depend on Japan and other countries for the raw materials and the equipments mostly from US, Malaysia, Singapore and Korea. And for rest of the items, we are depends on the China and Taiwan market. So that ecosystem is a big challenge where it puts a brake for the readiness to start our manufacturing process. But in spite of that, all the 4 companies which are already started their production line, we overcome this based on our collaborations with all the vendors. And there are plenty of equipment suppliers who are working with us here. And in fact, in India, there are 2 raw material suppliers. One is McDermott and another one is Autotech for the plating chemicals. So India is slowly growing on this aspect. In fact, I know that a couple of equipment OEMs, they plan to start their manufacturing in India, which is good for India, which will motivate, which can promote the semiconductor ecosystem in India, and with the support of the fab by Tata. And in general, the fab is a key point. So that fab could be ready in 28 or 29 time frame, mid-29 time frame. So slowly, the ecosystem in India will be ready in another 5 to 7 years time where there is the best possibility that India could be the leader in the market, where we can overcome all the challenges because India is a young, the population people having, where very good education system we have, we are very skilled, and the economy is good. So with all these things, I would say that we are ready to face this.
Awesome. It's great to see it's and the balance. I sense more positive momentum, which is great. I want to take two more sets of inputs. Personally, I think the hard infrastructure and bringing suppliers will happen. Fundamentally, you mentioned that India has 20% of global design talent. But design talent is only one discipline of talent that we need. We need whole set of specialization on chemistries, on metal forming, on quality management systems, on process engineers. Where do you see on our ability to build industrial grade, large scale talent of different specialization, right? From operator supervisors, quality systems, design engineers, quality engineers, so on. So where do you see that? And one question I would add there is, what do you think we should be doing, not just in the talent space, but talent, hard infrastructure, and supplier development in the short term, medium term, and long term? I would say 3 months, 1 year, 6 years.
I got an opportunity to talk to the inventor of MIMO, multi-input, multi-output, Mr. Arokya Sami Paul. He was a Emirates professor of Stanford. So he was telling, I just tried to ping him last week. I want to talk to you in Semiconductor Forum. What is your input? He is telling, the Indian conglomerates, Indian companies, or the whole world, the companies are focusing on earnings, market, or the profitability. We should change to VAR, value added revenue. It means what you do, you should generate and then make kind of a funding your R&D. So that it's not like running the business. You are running the business for the country. You are running the business for the people. So that is the cultural change should come. As of now, we are in sub-single digit of that contribution. So we have to change. So once the companies change, I appreciate, Paul, that one side we are getting a good support from government. That is not enough. The companies should change. They should start to invest in R&D. They should start in investing in people together on par with the technology. That's what the cultural shift or the way of running business shift what we are expecting. It's a very fantastic point. So I love to share with the people here. Then when we look at the people development, of course, we have industry academia partnerships. So we are trying to go closer with the government and trying to incorporate these technology to be implemented in the day-to-day their educational system. So that way you can address with the various curriculum from the assembler to the R&D. So that's what what we are closely looking at. So like every company has their different style of handling. I think Ravi has a fantastic showcase of a proven record of how they bring up the talent. So he will touch upon that. Every company has that. So with that in focus and the company way of running business, I could able to see that there is a tremendous shift in bringing our talent to catch up this demand of running these high complex technology products.
Companies focus on R&D and design and looking at talent as a strategic lever.
I think great topic, by the way. One of my key points. I'm really passionate about this space. So about 6 years ago, we decided to support centers for advanced electronics manufacturing at key institutes. And the idea was to put production lines on campus and full capability. What you would find at a manufacturing facility to put that on campus and sort of flip the script on its head in terms of really providing 70 to 80% hands-on training and about 20% to 30% of classroom training. And we started, putting, really scaling what Richard and team did, and putting that on campus and initiating. So Elon, clearly, and Paul's company as well has worked with us to do that. We've done 3 of those right now in the country. One at IIT Madras, one at College of Engineering Pune, and third one at IIT Kanpur will be coming up. The idea is to take it further. So this was just a model phase, right? We established the model, we showed that it works. We showed that the trainees can be capable of going out there and actually hitting the ground running. And it will help the ecosystem. The second part of it is to, there are 2 vectors. One is to move up and down the value chain. That means to go into packaging and also into the fab aspect. And the third part is to go downstream into the systems integration piece, and that includes design and systems level design as well as integration. So we're doing it one step at a time. So on the packaging side, we have seed funded 3, and the 4th one is happening as we speak. So IIT Bombay, IISc, and Shastra, and one more coming up. And Fab, we are also supporting. So essentially, 3 out of the 4 elements, we are almost there. And this would be quasi-production grade capability. So you're basically looking at what you would find outside. So clearly the talent development would be from the technology side, and the production side, it would be very pertinent, right? Because it's what they would encounter outside. But beyond that, you have to add all the other elements that you and Ellen mentioned, which is quality, reliability, all of the different aspects of going into a facility and a design and production unit. So all of those, it's a living, breathing system, and those will have to develop over time, and the companies, I'm expecting, will come together and support that educational ecosystem to, contribute the curriculum and support the development of it. So very positive outcomes so far. Our experiences have been incredibly positive. We've seen that. So that's one of the starting points. So effectively, I think the thing to do is to build very effective university, industry, government partnerships to execute this going forward. I think that's a quick snapshot.
Thanks, Ravi.
Yeah.
Yeah, as Dr. Arakyaswamy Paul mentioned, the VAR. I'm proud to say that Keynes is already in that, because we have formed our own R&D team in which we have 12 PhD scholars, almost all from IITs. So we know the importance of the R&D because semiconductor is not that easy. It is one of the very complex process, complicated as well. So we form a R&D team where they are working on all the new packages and how to develop. And in fact, they are working with McDermott on the material side also. And similarly on the skill set, realizing that, because basically I am from a mechanical background, but somehow I ended up in the semiconductor, fortunately or unfortunately. But I hope so I'm doing well because I learned a lot. Still I'm learning in the new packages, new technologies. So Keynes Semicon is working with almost 10 universities now. In fact, in one of the universities in Tanjore, we designed the curriculum for one of the semester as an elective subject, not only the theory part, that university, they established the semiconductor line. So they have done the clean room, they have set up all the equipments. For that, Kane Semicon is the backbone, and we have given the ideas. So once the students study the theory, they will have the practical experience, how the equipments are running, what is the process. So when they are come out of the college, it is very easy for them to get a job, or it is easy for us to recruit them, so that we don't waste any time. We can immediately post them into the line where we can get the throughputs. This is how we are working with other universities. And in addition to that, we have conducted online training on the semiconductors, particularly in the Gujarat region where we are. So there were 200 students from Polytechnic and ITA, and some from BTech also they have joined. What we have done, it's close to 4 weeks training program, online training program. After that, we have conducted online tests. Based on that, we have filtered out 50 students. Then based on the interview and furthermore, we have filtered 20. Then all the 20s were put up for training in our parent company in Mysore to learn about all the electronics and the ESD, whatever the nomenclatures with this electronic industries. Then after that, we have conducted an interview, filtered 11. So all those 11 freshers are with us now. So we want to continue this exercise further, and not only Keynes, now other industries also started this thing. Even Tata Semicon and CG Semi also, they have started. They are collaborating with the academic institutions to develop the curriculum, to develop the ecosystem, so that skill set will be useful for us. So as you asked, the near term, we don't have any choice because we recruit some people outside India. In fact, CG Semi or Tata or Keynes, we have some people from Philippines and Malaysia. That is the immediate term, short term, because we have to start somewhere, because India doesn't have that much skill set. So mid-term, already I mentioned, we have the freshers where we are trained them. By the time they will be ready. And we are working with all our OEMs that they are training our engineers. So that's the mid-term. Long-term, the academic institutions. That is the only way where we can generate the skill set.
I did want to add one thing, which is what we were talking about earlier. I think you've got to also start at the high school level. If you want a million strong workforce, then the way to do this is to start in 9th grade and get the kids interested in understanding electronics, playing around with kits and building stuff, understanding the fundamentals. So IIT Madras has developed a electronics kit, and it is now being piloted in Tamil Nadu. They're piloting with about 100,000 students, high school students, who can do about 30 to 50 experiments per year for 4 years. I'm told that we're supporting that. I'm told that actually they would be, if they did it diligently, they would be at second or third year engineering level by the time they finish 12th grade. The advantage of something like this and doing it at scale, today it's only a pilot program with tens of thousands of students. If you scale that by 100x in the country, easily possible to do, okay? You will have a 10 million strong high school student population working on this. Maybe 10% of them are passionately interested in getting into electronics, any part of electronics, right? Design, manufacturing, you can take your pick. But you have a million strong potential of people getting into the industry, and that's your starting point. Then it's a question of building a bridge program, right? Whether it be a vocational program like this kind of training we were just talking about, or whether they go into a scalable, flexible bachelor's degree program where they can walk away with a 1-year certificate, a 2-year diploma, or a 4-year degree. And IIT Madras has put that together with already more than 2,000 students signing up for that. And then the same industry-driven ecosystem that is built on campus can be used as a research test bed to develop master's and PhD level work. You have to, proactively build that. You can build that pipeline, and you can do it across many different fields. It doesn't have to be any one fixed area, right? We have to do this at scale. We have to fund it, collaboratively, I would say, and because it does require money. It's not going to happen free of cost, right? And it can be done. There's no question. The only question is how fast. And so we're doing all the pieces right now. The idea is to scale it.
No, when Ravi mentioned this, I immediately requested for one kid to introduce it to my elder son, who's in grade 9.
I got the privilege to look at the kid when I visited IIT Chennai. It was very fascinating, and it remembers my college days. So congrats to Ravi and team for that wonderful initiative. Yeah.
I think the common theme I'm getting to here is we are at a great path with a bright future. As Mr. Cherian said, we are a young population with full of energy. That is our secret sauce. And in the last round of conversation on talent, that can truly be our differentiator, right? Really sharp set of specialists coming out of it, being in the leading edge of innovation and manufacturing technology at scale. No other, and this is not just for us. I think it's a global value chain. This is folks who are going to have global careers as well.
I mean, I might add that if you notice the demographic trends, Japan, Korea, all European nations, they are all facing a crazy demographic situation. They need people. Otherwise, the economies they're all high-tech, super high-tech economies, right? So in my view, India becomes a major talent source for all of these economies. Not just developing our own economy, but, to me, doing this proactively will generate a huge dividend, not just for the domestic industry, but globally.
So one day I would like to see the world depend upon India. So now we are depending upon US for technology, we are depending upon Japan for material, we are depending upon South Korea for memory, we are depending upon foundry for Taiwan. I believe that in 6 to 8 years time period, with the startup ecosystem, every month we are getting thousands of startups are coming up. So we could able to get a good technology, product OEM companies, a great talent. So we need to make world depend upon at least 2% of the technology. Now we are in point 2, we'll go to 2 to 3% of the technology. India will develop. World will depend upon us. Thank you.
Thank you. I know I'm conscious of time. Maybe we can take one question from the audience for the panelists. Any? Yeah.
Thanks for taking up my questions. Myself, Santosh from Avendus Park. Yeah. My question is to Mr. Paul. So you're one among the EMS companies who have successfully scaled up the business and now venturing into OSAT projects and PCBs. So in your journey towards commissioning the first OSAT plant, what are the key learning curves that you would like to highlight to the crowd? And also, if you would do one or two things differently when you're scaling up your second plant, or so what is the learning curve? If you could highlight, that would be helpful.
See, I'm very fortunate that I am involving in 2 greenfield project, 1 brownfield project. So my first career was in Spell Semiconductors in Chennai. I was handling operations and business development. Then when I moved to Sahasra Semiconductors, it was a greenfield project. I don't know anything about the project, how it would be. But the learning started from there. The major challenge in the semicon construction or establishing the unit is that clean room. In India, there are plenty of pharma industries are there, but the pharma is something different from clean room. I mean, from the semicon. So clean room construction is the major one. Second thing is on the utilities, because semiconductors we need to use various gases and waters, the compressed air, all those stuff. So it is very hard to find who will be the proper vendor for establishing all these things. So the first project, it's very tedious to me, where it was very hard to find the suitable player to build that facility, but somehow we managed. And if you can go and see in the LinkedIn, the current CEO, Mr. Varun Manwani, has a detailed interview has given where you can see the plant, how it runs. So from there, when I move on to the second project, it's a brownfield. It is easy for me to establish that, and now the third one. But however, in India, for establishing a semiconductor, still we are not to the 100% up to the mark, in my opinion. Still we are lagging. That is where we have to focus. The learning is pretty much, even in the new greenfield, I am learning new things, because learning is the only way where we can grow up in our life. But semiconductor, we plan to construct another two main plants in Sanand, Gujarat. So the second plant is in construction. So based on my previous learnings, we have improved the implementation of all these utilities and the clean room. Hope I have answered to your question.
It was very helpful. Thank you.
Okay. Thank you. Thanks for the audience. Thanks to the esteemed panelists. Best of luck to all of us. Next year, same time, we would be in a next step, 2 steps ahead, and look forward to staying connected. Thank you.
Check. Ladies and gentlemen, let's give a huge round of applause for our moderator who handled this session seamlessly, and to all our panelists for handling this session seamlessly. May I now request Mr. M.A. Johar, the President, CP Plus Aditya Group Executive Committee member of LCNA, to please join us on the stage. Can we give a huge round of applause? Let's hear it for Mr. Sudhir Narayan, ladies and gentlemen, the partner Bain & Company. Mr. Alan Chelin, can we give a huge round of applause, the Vice President and Managing Director of Sanmina India. Thank you for your valuable inputs. Ladies and gentlemen, let's give a huge round of applause for Dr. Ravi M. Bhatkal, the Vice President, PhD Strategy, McDermott Alpha. With us on the panelists, we also had Mr. Paul Ilangovanti, Head Operations, Keynes Semicon Private Limited. Give a huge round of applause, ladies and gentlemen. I once again thank all the panelists, our moderator, for their great perspective on India's semiconductor leap.